Okay.
Did we start?
Yeah, we are live right now. So,
So nice.
hello everybody. Today, last session of the ML track is retrieval augmented end-to-end rack and evaluation with Nikhil. Nikhil is senior machine learning engineer at Gen AI team at Adobe, and he's gonna talk about evaluation, RAGs, and everything. And yeah, floors is yours, Nikhil.
Yeah, thanks so much, Mert. Hi everyone. I'm so excited to be here to give a talk on RAG and evaluation. I know many of you come from different backgrounds, so I'm gonna take it from a beginner level to an intermediate level, and then kind of give you some resources to follow up on. So let's start. So, what are the key takeaways for today? So, you understand different components of the RAG and some of the best practices and flows, some things to consider in productions. And there are a lot of pain points in the RAG these days. So, how do you handle these pain points? And finally, on metrics and evaluation. So, by the end of this presentation, you would have an understanding and idea on these components, and then you can definitely start working on your own RAG projects. So this is the agenda for today. We start with what is RAG and how it works, and what is the difference between RAG? What is RAG exactly? What is the difference between RAG versus fine tuning? And then we also look at some of the benefits of RAG. And we look at a design of a RAG question answering system. If you want to build it on your own, how would you design it? And then what pain points would you get while designing it, and how do you resolve them? And also we'll discuss on evaluation metrics and some of the recent developments in the field of RAG. Let's get started. So before knowing what RAG is, first we need to understand what LLMs are and their limitations are. So everyone might have used ChatGPT or any sort of LLMs like Claude. Um, so we did not have the latest information. So that was the main biggest challenge. So let's say the training cutoff knowledge was for the ChatGPT 3.5. GPT 3.5 was in 2021, and even now the training data has a cutoff, and then that's a problem as of now. And then hallucinations, so it only knows what it knows. So it uses world knowledge to answer your question, and sometimes that makes like the answer to hallucinate. And then it's not domain specific, it has the whole world knowledge. So it is always not domain specific, so you won't get most accurate information out of it. And then sometimes you feel like because these answers are generalized, you can't source it back to where it came from. Which source did it come from? So that's another problem. And these updates from OpenAI or any sort of enterprise will take longer times to get release new models. So we have to wait for the new models always. So these are some of the limitations of the LLMs. So on a high level, just let's try to understand what RAG is. So RAG is just a way to use our external data or some sort of information to improve the accuracy of LLMs. So instead of just getting the generalized answer from LLMs, we now know that where do you get your answer from. So RAG doesn't actually train or fine tune any LLMs. It's just an retrieval augmented generation. So it uses external data and kind of ground your answer to that specific source. So on a high level again, let's understand the flow, basic flow, how RAG approach looks like. So let's divide it into two phases. First phase would be the data ingestion phase, where mostly think about it like how do you ingest your data, how do you parse your data, and how do you store your data in a vector databases or document store. So this part is an ingestion phase. And then the other part is retrieval and generation phase. So where you focus mostly on how do you retrieve the content, relevant content, and then how do you pass it to LLMs. So if you see the flow, we start with data parsing plus ingestion. So we go and store the data in a vector database. And when a user asks query at a runtime, we try to retrieve the relevant chunks and then pass it to LLMs to get the final response. So this is on a high level. Don't worry, we get as we go further, we get in deep into the design, we get to deep into our understanding of each components. But on a high level, these are the components that we will use in our RAG flow. So just to summarize how the pipeline flow looks like, first step would be the document loading. It can be document, it can be image, it can be any sort of thing. And then document chunking. If you are, let's go with the documents for now. So the second step would be the document chunking. So we can't load whole document as as of it like into the a large language model. Let's think about a document with like 500 pages. So ChatGPT has something called context window. Um, so you can't just cross the context window. So it's like the number of tokens greater than 16,000 or 32,000, 32K tokens. So you have to have you, LLMs generally have these context windows. So you can't just pass the whole document into the LLM. So that is when you chunk the documents, and then each chunk of the document will then be embedded. Embedded is just trying to convert your text into numbers or vectors. And then we store those embeddings in your vector storage, and then context retrieval happens, and then we generate the answer. So these are the steps in a general RAG pipeline. So we'll get into the details of how things work. But before that, let's try to understand what chunking strategies are, and the basic chunking strategies that we have and how to go about it. So some of the chunking strategies that we see here are just by the character splitting, recursive character splitting, sentence splitting, semantic splitting, and propositions. So think about it like you have paragraph, and then you're trying to split based on sentences or based on characters, or based on a recursive character splitter. So let me show you something of what I mean by chunking strategies. Let me share my screen again.
Okay.
Okay, so if you can see my window here, so this is chunk visualizer. Um, so where you can experiment with few chunking strategies like basic ones to see what splitter you try to, if you want to try to use a recursive character text splitter, as you can see how it works. So let's take a chunk size of 50. So, and then if you go with character splitter, just character splitter, and then have an overlap of 20. So that will also uh, take an overlap, as you can see here. So which also helps LLMs understand better, so that we don't break the chunks in between. So this will help your chunks to keep some context with the previous chunks. So there are multiple techniques like this. So this is just to show you how generally chunks look like, and so that we have an understanding about the chunks. So getting back to the presentation, um, okay, getting back to the presentation, and uh, let's move to understand what vector database is. So now, as I explained before, we had a chunks of text, and then we pass it through and some sort of embedding model. And then that embedding model actually translates your text to vectors. So you can see something like this. And then we store those vectors in our vector databases. So vector databases are different from the traditional databases that you have, like SQL, NoSQL databases. Vector databases operate on a different scale in terms of latency, as well in terms of the algorithms that they're built on. So these help us with the latency, and they are very quick. in terms of retrieval. So that is where we use these vector databases. Some of the vector databases example are like Chroma, Pinecone, VB8, Elasticsearch, and Milvus, as well as Quadrant and other things that you can see on here. So and then but let's understand, because if you have used some sort of embedding model here, embedding models are can be open source embedding models or enterprise level embedding models. But before even trying to understand embedding model, we have to understand the difference between the sparse and dense embeddings. So again, repeatedly I might use embeddings or vectors which are like same. So let's try to understand the difference between the sparse and dense embeddings. So sparse embeddings are something like you have sparse where you have zeros and ones. Um, and dense embeddings are like you have always have a value to each and everything. So what is the difference between that? Let's say you have 10 words and then you are trying to only look at one word, and you want to understand how important it is. So you just mark that one, and the rest of the 10 nine words would be zeros. So that would represent that this is a sparse embedding of that uh, word. And but the dense will take all the words into consideration around it, and then give some weights to it, and that is what it is called dense. So dense will capture more semantic information, let's say how the meaning, the understanding the context around each word, whereas the sparse will only capture the count or things like that, term frequency. For example, example of sparse embedding would be term frequency inverse document frequency, TF-IDF. It's a very popular algorithm. And then dense embeddings example would be something like word to vec or BERT or sentence transformer embeddings. So, so this is the difference between the sparse versus dense. Now, just to give again an overview of what is the difference between RAG and fine tuning and a large language model. So where exactly do you need RAG? So first thing is even with the fine tuning, we can't get the information from the external knowledge sources in real time. So the RAG helps us there. And we can also, one of another area where RAG helps is real-time data, and it's actually efficient in developing like whatever we are trying to use in a real time. So that is where we kind of try to use RAG. And what some of the benefits? Let's discuss some of the benefits of the RAG compared to the native LLMs. So now that we retrieve from the external knowledge for more contextual relevant responses, so the relevancy is more and the quality will also be more. And because now we are not restricting ourselves to one specific domain, we can work on multiple domains, or tune our prompts to the domain for the RAG, and then we get an efficient retrieval. We can do a real-time updates and dynamic updates. And also we know now that our answer is grounded, we can trust the responses. And then we can also tailor which resources to consume, like source A, source B, source C. There are three different sources, but you want to consume it from source A and B and not C. We can control and customize that. So at every level, you have your customizing options. So that's where RAG helps. And now let's talk more about the applications in real world. So few of applications are in conversational AI, like building chatbots, which is quite popular these days, and then some sort of advanced question answering system, giving some context, and then some content generation, just like LLMs, but again more recent relevant facts and statistics from the real time data. And then again you can build some reasoning platforms and search platforms and retrieval platforms for the specific domain. So these are some of the applications where you can integrate the RAG. Now let's try to understand some architecture of how do you generally build a question answer RAG based system, and what sort of components do you consider it. And by the way, we will take all the questions towards the end, so that everyone will finish the presentation. So I'll be sharing the flow for the question answering system. So as you can see, if you want to build a question answering system based out of RAG, so earlier I've mentioned that there are two different phases. One would be your data ingestion phase, and one would be your data retrieval slash generation phase. So let's walk through this for a few minutes, and then we can go to the next slides. So first part of this would be having your document. Then the second part would be the parsing the document, which is like load and transform. As in the terms of data engineering, it's like ETL, but we are just loading the document here. So first thing I would suggest anyone would start with is uh, understand different techniques on the ingestion side. What are the best tools that you can use to parse PDFs or different formats of the document? And then I explore and experiment on different chunking strategies that we discussed earlier, and then do some parameter tuning like change some chunk size, overlapping, and these are the some of the chunking strategies I discussed earlier as well. And you can write your own custom chunking strategies. Now that chunking is done, the next part would be pass these chunks through embedding model and then store it in a vector database. Milvus, V8, Pinecone, you can do it in any sort of vector databases. Now, as this part is done, the second stage would be when in a runtime, when a user asks a question, it then goes through something called guardrails. So what are guardrails? So guardrails are something like, okay, is the user question, is it toxic, or does it have any bias, or does it have any sensitive information that you should not answer? So things like that will be checked at the guardrail stage. Now, once it passes through the guardrail stage, we then do some pre-processing and then pass the same query through embedding model as well. Now, the reason is we wanted to compare our query with all the text chunks present in a vector database to find the similar chunks, and then that would be our context to the LLM. So instead of passing the whole document, we might only pass relevant chunks from, let's say, a 500-page document. We might only pass like 2 to 3 pages which have relevant text. So that way we are saving the costs, we are grounding our answers, and we are getting our better retrievals. And then the top K chunks are the ones that are called context. And then once we have them, we can do something called re-ranking. And there are a lot of re-rankers out there. And then we take that context, pass it to large language model, get an output in some format like query results, and then what are the source documents. And then once we have these sort of results in any sort of schema, we can then use it to evaluate and then store some evaluation metrics back in our databases for some improvements or user feedback, things like that. So on a high level, this is an architecture, but if there is time, we will revisit this towards the end. So getting back to the slides. Um, So now that we have discussed the design and architecture of the RAG, we will try to understand what the pain points are, and then let's see what solutions exist for those pain points. First thing would be on the if our data is wrong, like if the data is not is bad. Let's think about a PDF that's not good, or let's say we have, even though you have a PDF, we don't have good chunks or good answers present in our document. So document is completely related to some wildlife photography or something, and then you are asking something related to fast food. So it's two completely unrelated topics. So first way would be you might miss the content as a whole in your database. So even the proposed solution cleaning in your data and better prompting might not give a result, but you can try, because your question generally would be grounded. Would you would ask something related to document. So when that is when you have to clean your data better and do better prompting, so you would get your content better at this stage. And then coming to the second problem that we might face is, now that you have retrieved chunks, but uh, but what did the order of the retrieval is right or wrong. So let's imagine that you have retrieved 5 different chunks, but what if there is the order is different, so that the priority will be different? How do you make sure that the order is in the right format, so that you know, okay, this is the relevance. This first chunk has more relevancy than the second chunk, than the third chunk, than the fourth chunk, because even the order matters here, because uh, the more the relevant, it has to be on the first position or second position. The less the relevant, it should go down. But what if the order is missing? So that is when you do something called re-ranking, and that will put your chunks in a right order and at the retrieval stage. So the third point would be whether it's present, the rank chunks are present in the context or not. So for that, you have to use some embedding models, strong embedding models, like large embedding models from OpenAI, Cohere, or any sort of open source ones that work on your data sets. So it's more about experimentation. And then fourth point would be about whether it is extracted or not from the um, from the output. So from the response, whether you see like whether it's extracted or not. So for that, you have to um, go about, like, let's say my context is so huge, so LLMs can't process. So try to reduce your context by using like compression techniques and prompt compression techniques like LLM Lingua or other things, where you try to compress your prompt to get the answers. And there is a biggest problem is that the answer is in the wrong format. So that we always get this problem in production systems, where we have a specific JSON to be a format to be output, but we don't always get that as an output. So that is where you use Pydantic and some JSON schema modules, and then other things like structured outputs from OpenAI, things like that. So on a high level, these are the things that one will have to focus on, because these are some of the real world problems. And then going to the eighth one, I'm going to skip few, and then going to eighth one. So you have your chunker, but you don't have to do it sequentially, because it will take a long time. So that is when you parallelize your ingestion process. Uh, and you can, and for the ninth point, let's see, it's a structured data question answer. And you'll have to understand whether if it's a, structured data or unstructured data, and then do the processing accordingly. And how do you deal with complex PDFs? It has more tables, or tables within a tables, or things like that. You have to use better parsing techniques. And then what about the fallback model? So let's imagine there was some error in the processing of your pipeline. So you always have to have a model 2 or a fallback, so that if the model 1 fails, it always falls back to the model 2. Something you can think about it like model 1 is an enterprise grade model, and model 2 or a fallback model would be something like an open source, or it can be another enterprise model as well. And then coming to the LLM security, it's mostly about your guardrails, and it's about our guardrails, and then protect, not adding PII bias, toxicity, these kind of things. So we'll discuss more on this as we go into the next slides. Again, a few of the things that one should consider in production track is, first one would be your have to do parallelize your data ingestion workflows where think about like how you can parallelize your chunking part, so that would speed up the ingestion process. Because the main problem with the RAG would be the ingestion, because think about the documents that are so huge which you want to ingest at the runtime. So no user would wait for so long to get the answer. So ingestion parallelizing in data ingestions is really important. and and that there are like different vector databases that you can choose from. Some vector databases have efficient algorithms uh, to store and retrieve quickly, but some vector databases support things like advanced hybrid search or things like that, but some vector databases don't. So always look at the pros and cons of your vector databases that you're choosing, and then proceed accordingly. And also choosing efficient embedding models is important, based on your data set that you have and then the amount of data you process. And having a good caching strategies is really helpful for response times. And building some async workflows for again chunking, generation, and then streaming output would be good. Um, so let's imagine a case where user is typing a question, and then he has to wait so long for his answer. So that is not an ideal case. So it is always better to stream your output, so that he or she can always see the output in the real time, at least for the first token. So time to first token is one of the important metric to track. And error handling and retrialing mechanisms and fallback models, as we discussed earlier. And then prompt injection, PII, bias, and toxicity is another important factor that we have to consider in production systems. What I mean by prompt injection is that any user can come and ask a question, and that might be related to something else. He might try to trick the large language model to give some sensitive information back, which has to be taken care by the system. So that is when we integrate some prompt injection mechanisms, so that user can't be able to get the sensitive information out. PII is something similar, so where we kind of uh, focus on those details like names, credit card numbers, and then blur them, or mark them as personal identity information, so that they are not visible to anyone or the model. So and then coming to bias and toxicity, these are some of the things that can be handled using models or using prompts, and there are different techniques to handle. But again, this is a big problem to handle in the production systems, and is very important. And the next things that one should consider is the evaluation mechanisms. And this time, it's not about human evaluations; it's about auto evaluations mechanisms. How can you create your own auto evaluation frameworks for your system, and then add more metrics into it, so that you can keep track of your production systems and then kind of improve on top of it. And also, there is this observability to understand how each of the transaction or how each of the request flow looks like, and that way you can identify which part of your pipeline is taking time and then try to optimize that. And you can also do error catching and everything with the observability. So now that you have an idea of whole understanding of the RAG flow and some of the things to consider in production, we will discuss more about metrics and evaluation part. So before discussing about RAG metrics, first one has to understand some of the basic information retrieval metrics, like um, how do you generally evaluate your IR metrics, information retrieval metrics? So these metrics existed from long time. These are not new, but they existed from long before the LLMs. But so let's think what sort of metrics one will measure. So there are two different metrics: offline metrics and online metrics. Offline metrics are something that you calculate on your end, locally, with some sort of ground truth, yes or no, if that is present or not. And online metrics are something that you calculate on the go, on the fly. Like think of it like a flywheel, where you calculate it on the go, on in the online. For one example, I would say is like a click through rate, or hit rate is one sort of online metric. For offline metrics, things can be like precision, recall, F1 accuracy, um, and other things, as you can see here. So let's discuss about order unaware. So what is order aware and what are order unaware? Um, I don't want to go in depth, but again, so it's about when you get retrieve few output results, are they in the order or not? So if you want to know, if you want to also measure your output based on the order, that is when you consider MRR, MAP, and NDCG, distributed cumulative gain. So if you want to do order unaware, you can go with these metrics. So the reason why these are important is that if you remember from the architecture diagram, there are top k chunks retrieved from the vector databases. So that is where you measure your retrieval metrics, how good your retrieval retrieved chunks are. So these are some of the metrics that you keep track of, um, uh, and will help you evaluate your whole system. And there is one framework, especially for this, it's called Ragas, where you have some basic metrics like these: faithfulness, answer relevancy, context recall, context precision, utilization, and recall, entity recall, and then if you are doing a summarization, there is a summarization score. So I will also share this links after this presentation, so you can refer to that. And the next thing would be to understand the challenges in the RAG. Um, what are the existing challenges, and then how do you overcome them? So a few of the challenges are chunk sizes and parameters should be tailored to specific use cases. So a lot of experimentation has to be done on that area to figure out your specific chunk size and parameters for your use case. And then you have to have your own evaluation benchmark set up as a combination of retrieval plus generation. And using a good re-rankers is efficient, and make sure that it doesn't slow down your overall system. This is a challenge. And adding some of the metadata to the chunks can improve your performance, but it's a challenge to add metadata on a different scale. Um, and setting up auto evaluation metrics and observability is a challenging part, because again it varies case by case, domain by domain, and trying to generalize it is really a challenge. Some of the recent advancements are in the domain and the future work are self-RAG, CRAG, and RAG fusion. And then also you can look at Cole-Pally RAG and the challenges, Cole-Pally RAG as well. And then, so given the time constraint, I'm going to just skip through it. Um, you can try to understand what chain of thought is, action is, and then react is from these examples, but I'm going to skip it to answer more question. And then recently, there was this paper called Cole-Pally, where it uses vision language models to answer your queries. So this kind of reduces the latency and improves our metrics a lot. But it hasn't been tested on a production systems, but it should work um, well. But this is what is one of the things that you can try to explore. And then, so yeah, what's next? What's next in the field of RAG? So you can add your long-term memory, and you can add your own personalization to your chatbots that you build, and then you can add multilingual support. Think about languages, other languages like French, German, Portuguese, um, Turkish, Farsi, any languages. And then think about what can you use as a tools. Like you can use some external tools, you can connect it to your chatbot so that it can retrieve information from them. And then think you can also do some intent-based routing or query-based routing. So based on the question, you know which tool to call or things like that. And then you can do metadata or semantic routing. You can build your own agentic AI workflows. And setting up custom auto evaluation frameworks. Like, okay, I have this new metric and I want to track it. I want to write some prompt based metrics. You can do that. And then building production ready graph rag applications, that would be the next step. Thank you. I'm ready to take some questions. You can connect with me on LinkedIn.
Thank you, Nikhil. It was great presentation. So Alexandru says he has some experience in Iraq from his internship. What would you recommend him to learn to become expert or proficient or even become more familiar in Iraq?
I would say if you have building things is the best way. Starting with naive rag, um, try to accommodate complicated pieces into the system, take some more complicated data, see how it's performing, and doing analysis. Take the fixed set of data first, which had like distribution of um, different type of documents, and then different complicated documents, and then different structures in the documents. That way you know how good the overall system is performing, and then explore the areas of chunking, explore the areas of different trying techniques like hybrid search, and then re-rankings, and then retrieval and optimization on the retrieval side of things. So also uh, there's like it's like an experimental thing, so you will eventually learn. So it's not a um, it's not straightforward approach, but yeah, definitely I can share few resources. Yeah, let me know. Yeah.
Have some. And also, what would I say? Like, I built a lot of projects from hackathons, but when I joined the company, I just helped the team building a evaluation pipeline, and that was whole different experience, like end to end building an evaluation pipeline and solving every tricky problem that data has, like dirty data has. And I would recommend like building an evaluation pipeline.
Yeah, definitely. So evaluation again is a tricky component, and there you can always add your own custom metrics. Think about like, okay, I want to do my own hallucination metric. I want to create it on my own, build my own prompt to do that, handling all the cases. You can use LLMs to judge your evaluation. Um, Things like that. You can always do those, and that are being done. Like multiple companies do that. So
Yeah. So any other questions, folks? Because I have a lot. Okay, another question is, so are there any kind of tips and tricks when you're safeguarding your RAG pipeline or like your LLM after the prompt engineering techniques? Like most of the time, you're doing safeguarding on like changing your prompt in a way that guard your uh, LLM to and like answer bad questions or like unethical questions. So, are there any kind of tips and tricks or ways to do safeguarding?
yeah, there's always because in a production systems we always have content moderation in place, so that any sort of question that has bias, toxicity, or harmful things will automatically have get the responses back from the content moderation model itself. So let's say imagine that you are using OpenAI as part of your building your enterprise application. So OpenAI has this content moderation thing where you get your responses back if there is like a bias, harm, or toxicity, or any sensitive information. It just returns back the user, so you can process this in a request, um, things like that. So as an AI model, I cannot answer this question, things like that.
Yeah, 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 yeah. And also that there are some kind of llama
guards.
models that
Yes.
already has some kind of safeguard or like
Yes.
guardrails.
Yeah, you can use a combination, but yeah, completely up to the implementation. And then let's say your data set has 100 data points, and then let's say if 90 data points are being crossed, 95 data points uh, are good enough. So you have like 95% accuracy in um, safeguarding the elements, but you have to be 100% in this case. So that is when yeah, I can trust more on the enterprise level ones, but llama ones are also good. I can try those as well.
Sounds good. So Alexandru says he used Gradio to deploy RAG applications.
Okay,
Uh,
but on an enterprise level, it's a different story.
yeah, you need to build like a whole backend, front end systems for your RAG application.
Right. So
And
as part of proof of concepts or trying an experimentation, that thing should work like a streamlit Gradio or any sort of things should work to do the experimentation phase. But yeah, to deploy and scale, not sure that would be good approach.
yeah.
Yeah,
Also, Nick says any thoughts on tree versus graph for chunking a corpus that includes highly interrelated info like code?
yeah. So GraphRag is something that you can use definitely. Think about like so companies like Meta or who works mostly on graphs, right? Who has a corpus of graphs or data of graph data, so they can always build some applications that are related to graphs. If they have a knowledge graph databases, and then they already pass the data and then store them as a graph databases, graphs in the graph databases, like let's say Neo4j is one example of the graph database. So they can directly fetch from there and then process those graph chunks. So that is something you can do, because in the graph rag it is like you have your all your related nodes connected to each other, so you know which one to parse. So that's an advantage with the GraphRag, but the only problem I see with the GraphRag right now is kind of building a graph is what is going to take a lot of time, which means the ingestion process is going to take huge time compared to the vector database. So in a real time, if you want to build graph at the runtime itself, is going to be computationally expensive.
Yeah. And do you think like Cursor has some kind of graph rack at the back end?
I think it should. I think it should. Yeah. It's a combination, I guess. It's a mix of
Yeah,
vector search plus the graph approach.
because graph makes sense when it comes to code, definitely.
Yes. Yeah, you also have code chunkers, but let's say you have chunk your code and then tried it as stored it as a vectors, but graph makes more sense here because of the dependencies.
Yeah. So
Uh,
any other questions?
I will wait for 2 more minutes and then yeah.
Yeah. And also maybe I can ask you about Colbert. So I heard Colbert from somebody else too, and I'm really curious about what is it, what it
Okay,
is.
let's do that. Okay. Can you see my screen? Let me know if you can.
Yeah,
You
I
can,
can see
right?
it.
Okay.
Mm-hmm.
Okay. So Colbert is what is being used in Colpali rag. But what exactly is Colbert is that, let's imagine that in earlier cases in BERT, you know how BERT works, or you guys know how BERT works. So you have your query, you have your document, and then if you want to compute the similarity between each word and the document, you have to do all-to-all interactions, which means if you want to embed this document, you have to also know query, and based on that you try to embed your document. So which means that the query and the document, it's like all the tokens in both have to interact with each other. So that is computationally expensive um,
Mm-hmm.
in the runtime. So that is when they proposed Colbert. What it does is, instead of using all the tokens, it only takes the last layer of the query and then last layer of the documents, and then only computes the similarity between the last layers of both query and the document. So that it also embedding also takes consideration in the query. So it the document gets embedded based on the query in real time, but it also has context. Generally, how we do the embedding is that query embedding is separate, document embedding is separate, just like as it's shown here in first A, right? But in case of BERT, we do tokenize, we do convert to vectors, and then we compare all to all interaction, and then we get the final similarity. But in the late interaction, what it does is it also takes query, but the last layer of the query and then the last layer of the document, and then computes the similarity between, so that it also document is embedded in a way that it also knows the query. uh,
Mm-hmm.
so how that is one of the advantages of Colbert. Now, where exactly the Colbert is used? Think about, you can't use it to uh, get retrieve all the documents because it's so computationally expensive. But that is when
Yeah.
you use it at the re-ranking stage, where you have, let's say, 10 chunks or 20 chunks, 15 chunks. You can afford there. You can afford using re-ranker or late interaction, any late interaction model or any other re-ranker there, because it's fairly on 15, 20 is nothing. You can do it quickly. But uh, with lots and lots of documents, no, it is not a good idea to use the Colbert.
Yeah, gotcha. And we have another question from Anup. He's new to Rags. Where do you see Rag shine in terms of application?
So think about, again, applications related to reasoning. Think about applications related where you want to pull the external knowledge and then synthesize the data and create a chatbots, create a um, voice-based chatbots or any assistance for you. That, let's think about an application where you want to have all the knowledge that you need, and create your own brain, and then you try to answer any sort of question from that brain specifically. So you can think about applications like that.
Yeah. And also, I have another question before asking Nick's question. So, wh- most of the time, when small business, like small companies, are building something with RAG, I think, yeah, it has business value. But when it comes to big tech companies, you can see the difference. You can see the real value coming from the generative AI applications, right?
Right. So s- I mean, yes, because the data is so huge, and transaction and each of the request will actually, over the scale, it will generate a lot of revenue, because I think everything these days is subscription based.
Yeah.
So yeah, totally makes sense.
And yeah, Nick says if you want to talk about sparse versus dense embeddings, it's the one he doesn't think it's well understood.
Yeah. So sparse and dense embedding. So generally, we have different types of embeddings again. But let's imagine sparse. So if you have an idea of TF-IDF, how it is represented, so it is the best example of the sparse embeddings. But um, so just to again reiterate, let's say you have 10 different words with you, and you wanted to find a word in that. So you just say everything to be zero, and then wherever that specific word exists, you mark it as a one. It's called one hot encoding. So that's a simple way to put sparse embeddings. So let's say it's going to be like 0 0 0 0 0 1 0 0 0 0. So which means that wherever the one existed in that, that is a simple representation of that word. That's a sparse embedding of that specific word or token. Now, dense embedding is also like it also takes your surrounding words into context. And if you are looking at the sentence level, and if you are looking at a paragraph level, it's going to take that whole words, sentences before and after into context to get this uh, representation, like representation of this sentence in different vectors that values differently, and then you can normalize it to have values between 0 to 1. So think about like the quick little brown fox whatever as a sentence, and then you have your we want to represent the fox as a fox as a vector. So it'll also take a quick little into context, and then whatever is after fox also into context, and then try to represent this as an n dimension vector um, uh, in a vector space. So yeah, that is on a high level, yes. But you can definitely Google to learn more about like dense embeddings, because it's difficult to explain orally, but it will be very easy if you can visualize it with a video or any sort of embedding projector uh, online.
And when you're building, when you're embedding your content into vector database, which one is mostly used? Is it sparse or dense?
So sparse is used when you wanted to give priority to um, keyword search. Simple, like think about like TF-IDF and BM25
Mhm.
are almost same. Like it's based on TF-IDF. So if you want to do a keyword-based search, then sparse embeddings works better. But if you want to do um, a semantic similarity search, let's say you wanted to type something similar to your data, but it's not same, exactly same.
Mhm.
So, but it conveys the meaning to be same. Uh, that is when you use dense embeddings. But now think about combining both sparse embeddings and dense embeddings. Uh, that this is what is called hybrid search, where you take both sparse embeddings and dense embeddings and combine them together, so that it also knows the keyword and it also knows the semantic similarity as well.
Yeah, that's great. That was really great explanation.
Thank you. Um, yeah, so regarding this sparse and dense, I would definitely suggest taking a look at the images or PDFs. I think that's the best way. Or there is a website called some sort of embedding projector website where you can look at the different vectors, um, and then try to understand how they are located in the space, vector space. So I think it's from the TensorFlow, right? If you
Yeah,
remember.
it's from the
Yeah,
TensorFlow. I was just gonna say that, and I just
yeah. Oh yeah, you just posted it. Yeah, that's the one.
yeah.
Yeah. So yeah, this one actually will help you just to get an understanding of the vectors and the dimensions.
Nick says, is it very difficult to implement the combo, like the hybrid search?
N- no, not really. So all the vector databases right now um, does support um,
Mm-hmm.
does support the hybrid search, almost everything. So everything is abstracted code wise, so you don't need to implement anything. You just have to give passing parameters. It's as simple as that. And then just give weights, like how how much of a weight should sparse take and how much of a weight should dense take. Like similar to like how much should I weigh the keywords versus how much should I weigh the semantic similarity search.
Yeah,
So it's a combination of both.
I have some. Any other questions? So maybe last question from me.
Yeah, go ahead.
So when you have like relational database with multiple uh, data tables, how do you integrate LLMs into this kind of database?
Can you repeat the question again? So you have a tables on.
Yes, so you have relational databases like probably on the PostgreSQL, like and how do you implement LLMs or like RAG applications into this kind of domain or like use case?
Yeah. So if I wanted to think about it, I would first try getting the tables data based on user
Mhm.
input, but which means that um, are you looking? I know Postgres also has a vector database
Yeah.
recently, so if you want to take export it to that, that's one option, or you can just take it to your native vector databases again as VV8 or in Pinecore or any other sort of databases.
Mhm.
How do you query? How do you get your relevant data? I think it's completely depends on the use case. um, just to ingest the data part. So once you have your ingestion and then connect these, because in Postgres or any sort of relational databases, these tables are linked to each other, right?
Yeah.
Based on the keys. So that is when you need to understand, okay, what sort of tables are connected and what sort of tables are not. And then based on that, you can actually vectorize them, store them along with their metadata. Like,
Mhm.
okay, if I refer to this table, I also should refer to other tables as well.
Yeah, makes sense.
So yeah, because everything is connected. All the tables are also connected. So if you are referencing to one table, you also need to have some sort of metadata where you store these other tables as well.
And also, I need to do some kind of data modeling before doing that, right?
Yes,
Okay.
yes. It's again, if that's the case, then the data engineering comes very handy here. Yeah, yeah.
Okay.
That's the use case. Yeah.
So Luis asks, have you heard of table augmented generation for answering natural language questions over databases?
Um, Over databases, it's like something like text to SQL. I think I've
Yeah,
not,
probably.
yeah, but I didn't explore it much, so I can't talk much about it. Yeah, but there are like uh, text to SQL models out there already. But I'm not sure like how we can relate that to our databases. Yeah,
Probably text to SQL is the way.
yeah,
And we have 1 minute left. It's almost 1 a.m. for me, but I'm so energetic
okay,
because of this session.
yeah,
Okay, then let's wrap up. I already
sure,
posted the LinkedIn profile and the TensorFlow projector, and also
amazing,
you can share anything after the session, so the chat is reachable after the session. And yeah,
definitely, yeah,
that's it then.
that's it. Yeah, thanks so much, Mart. It was really nice talking to everyone. Yeah,
My pleasure, Nikhil, and it was awesome to hosting you with this great presentation about track. And yeah, have a good one. Bye bye.
amazing. Yeah, see you everyone.
See
Bye.
you in the next day. Bye bye.